Okay, guys, as I was going through your 7.5 worksheet that a bunch of you have turned in already, quite a few of you had additional questions that you asked. Thank you. That is exactly what you guys are supposed to be doing. Write me a comment there saying, hey, Mr. Fontana, I needed a little bit of help with this problem or that problem, and I'll go through them here and work them out, and hopefully that'll make a little bit more sense. So the first question that actually two of you asked about was problem number 2, and as I'm looking at it, I'm not surprised that you asked that question at all. This is the diagram that we have. We have a large outer triangle, and then another line segment has been drawn inside the triangle parallel to the third side. So this is definitely a side splitter problem. But what's a little bit tough about this, and it's different than the ones that we did in class, is that when you go to set up your proportion, you were not given the exact same corresponding information on both sides of the triangle. If we take a look at this left side right over here, we've got a 2 for the small piece up on top and a 5 for the small piece down on bottom. Now, as we look at the bottom side right down here, they didn't label this really well. That 3x plus 2, I can only assume goes from this point to this point right over there. And the 14 that they've given you, if you look at the arrow, represents the entire bottom side there of 14. Now, what I want to point out that makes this problem difficult here, that blue arrow means that you were given the length of the entire bottom side, but I'm going to switch to blue here so we match. We were not given the length of the entire left side over here, but you were given the lengths of the two pieces. The 5 right here and the 2 right here means that our entire left side is going to have a length of 7. So you've got to make sure that you're comparing apples to apples right here and corresponding parts when you're setting up your proportion. Now, again, there's a lot of different ways of doing this, but I'm actually going to start with the piece that we want, which is the 3x minus 2 right here. So I want to make sure that I include that in my proportion. Now, let's think about what to put under that. The 3x minus 2 represents this piece right here on the bottom. The corresponding part over here on the left would be this 5 right over here. So the 3x minus 2 corresponds to the 5. I'm going to put the 5 underneath that. Now, what I think a lot of you guys probably wanted to do was to know this piece right here and have it correspond to the 2. That certainly would have been easier, but they didn't tell us the length of that piece. So instead, we're going to use the entire bottom side, which has a length of 14, and compare that to the entire left side, which we had to figure out had a length of 7. So that information was not presented to you directly. They gave you different kinds of info on both sides, and you had to make sure that you, in this case, you added those 2 and 5 together to get the 7, so we had the right info. Solving this hopefully isn't the problem. We're going to multiply 7 times 3x minus 2, and that is going to equal a 5 multiplied by a 14. We'll distribute the 7 here and get a 21x minus a 14 is equal to, and 5 times 14 I believe is 70. We'll add 14 to both sides and get 21x is equal to 84. Dividing by 21 now, we're going to get x equals 4 for the answer to number 2. So that's a tough problem, and I'm glad you guys asked that. As we take a look at number 11, this actually is something kind of similar to the problem that some of you guys had on number 2. It's different than the problems that we did in our notes and some of the other ones, the easier ones that were on this worksheet. So let's take a look at what's going on. This is the one that uses the triangle angle bisector theorem. You have this segment drawn inside the triangle that bisects one of the angles. And so what happens then is we end up with a proportional relationship between this 9 and the 3 and the 2x minus 2 and whatever the length of this piece is right here. The problem is they didn't tell us the length of that piece. They gave us 7, and that 7 represents the length of the entire right-hand side. We need this piece that goes right here. But as soon as we think about it, we can probably come up with it fairly easily. If this whole right side has a length of 7, and the bottom piece takes up 3, we just subtract and get 4 here left over. So my proportion here would probably be 9 over 3. 9 is to 3, as 2x minus 2 is to 4. Again, there's 8 different ways to set up one of these proportions, so yours doesn't have to look exactly like mine, but on the next step they should be identical. The 3 gets multiplied by a 2x minus 2. The 9 gets multiplied by the 4, and we'll distribute here. We're going to get a 6x minus 6 is equal to 36. We're going to add 6. Nope. We are going to add 6 on both sides and get a 6x is equal to a 42, and then divide by 6, and we're going to get x is equal to 7. All right, so these two problems were a little bit different, a little bit more difficult than some of the ones that we saw earlier in 7.5. Great job asking questions on those, guys. We might see those again on the review or on the test later today, so let's make sure we follow what's going on.